Hello, it's OG Math Mosley. Today we're going to be talking about finding the rate of change and y-intercept for a line. All right, so let's get started. All right, so here we have our first scenario here. We're given a graph with a line on it. And our first task here is to find the rate of change or slope. Those terms are interchangeable when we're talking about a line of the line. And we've got this red line going through here. We need to find the slope. All right. Easiest thing to do is pick points that we can easily identify the coordinates. All right, so I'm going to pick a point right here, a point right here. This first point has the coordinates of -3, 0. Right, and this second point has the coordinates of 0, 2. All right, and so we can kind of see, without doing a ton here, that we have a change in x, right? I'm going in the positive direction to the origin. All right, so we added +3. All right, and then we had our change in y here, right, of +2. Right? And we know that our slope, or rate of change, right, is going to be, let's say slope, all right, is going to be the change in y divided by the change in x. And in this case, that's going to be 2/3. Right? We could put this as a decimal, but when it comes to lines and graphing and reusing this formula for something else if we needed to, that's less useful. Leaving it as a fraction is actually preferred because it's easier to use, right? The decimal for this is 0.6666666666666, and it never ends, and that's annoying. So we're going to leave it as the fraction here, and this is our slope or rate of change. All right, so our first question is done. Woohoo! All right, then we need to find the y-intercept. Oh, this is great because we actually already used that point. It was the second point we chose. This is where my line is crossing the y-axis. We have our y and our x-axes here. So y-intercept, all right, well, we've already found that. That is at the point 0, 2, right? Our x value is 0, our y value is 2. That is the y-intercept. Sweet. All right, and then we need to write the symbolic rule for the line. Remember, the symbolic rule, or the one that we're using right now, is the what could be called slope-intercept form, and it has the form of y equals mx plus b. You can also write it as y equals, sorry, not b. Get my letters in the proper order. You can say a plus bx. You might see it in that form. They mean the same thing. It's just the y equals mx plus b is used more throughout, let's say, like grade level math, where m represents the slope and b represents the y value of the y-intercept. It's kind of what's just used more common, right? So we already have the pieces we need, right? We have our slope, which will replace m in our formula. All right, and we have the y value of the y-intercept. This will become b. All right, so in our rule, we have y equals, let's use colors to make this nice, 2/3 x. In this case, y is positive. The y value of the y-intercept is positive. All right, so we do +2. If it was a negative number, we'd use that -2. But this will be +2. There you go. There's our symbolic rule written in slope-intercept form. All right. Lastly, we have what's called the now-next rule. This is another form of rule that is more of a written sentence saying how to go from one y value to the next y value. It's really kind of its use. It would be considered like an algorithm. It tells us the rule on how to do something. So we can say now plus, and this is where the slope comes in again, 2/3 equals next comma, starting at, and now the y-intercept comes in, the y value of the y-intercept comes in again. We're starting at 2. Now, these now-next rules are most commonly used within a context in which the start value is the reasonable value to start with because you're not going into negative values. Like, you know, someone starts with 2 t-shirts in their closet and they're adding something to it. It doesn't make sense to have negative t-shirts. So you have an actual starting point, a starting value. A base salary, for example, could be another example. All right. It doesn't make sense to start negative. For just a graph with a line, and now next rule doesn't make a ton of sense because obviously we can have negative values on that line for a starting point. Again, this is just another way, an algorithm way of representing what's going on in the line. Right? If I pick a point that I start at and I add 2/3 to it, I'll get to the next point. Next, we're going to scroll down our page here and look at how do we use a table to find the same set of things that we just found above. All right, so let's look at this here. We need to first find the rate of change, or the slope, of the line represented by this table. This table is a little bit jumpy. Right? We go in this from the first x value provided to the next. Make this a little bigger. Right, we're going up by 1, then we're going up by 2, right, then we're going up by 3, and then we make a jump of 7. Right. Lastly, we make a huge jump of 15. So we're not being super consistent, but that's okay. All right. We know I'm telling you that this represents a linear function or the coordinates on a line. I just need to find the slope. So I know that the rate of change should be consistent. So that means I can pick any 2 pairs of xy values to find the slope. It doesn't matter that I'm not following a 1-by-1 increase on x to find the change in y. Right? I just need to pick 2 points and find the change. Right? It should be consistent. We'll confirm that. We'll do it in a couple different spots here. So if we look at our first pairs, right, 2, 0, and 3, 1.5, this says I increase 1 in x, 2 to 3, and on y, I'm having an increase of 1.5. So the assumption, our guess would be that the slope is 1.5. Right? Now to confirm that, let's pick another couple set of points. Right? We have between 8 and 15. We go up by 7 in x, and from 9 to 19.5, right, we're going up by 10.5. All right, so let's check to see if I get the same rate of change using both of these sets of points. All right, so in our first one, we got a plus 1.5 as the rate of change. Right. If this works out the same, I should get 1.5 as the result. So if I do the change in y, right, again we have change in y divided by change in x. Our change in y was 10.5. Our change in x was 7. Right. If we do 10.5 divided by 7, well, that's going to be 1.5. Right. Half of 7 is 3.5. 7 plus 3.5 is 10.5. So 10.5 divided by 7, again we get 1.5. This is good news. That means our slope, the rate of change, is 1.5. Awesome. So we have that. We need the y-intercept as our next thing. Right? I do not have the value of y when x equals 0 yet. It's not on my table. All right. But I know when x equals 2, y equals 0, right? I need to subtract 2 from x to get to 0, which means I need to subtract 1.5 2 times. All right, so let's look at this. 1.5 times 2 is going to be 3. All right, so then I need to subtract 3 from 0. All right. 0 minus 3 is negative 3. All right. That means when x equals 0, all right, I move 2 steps backwards on x to get to 0, then y going backwards 2 rates of change will land at negative 3. All right, so negative 3 is the y value of my y-intercept. So my coordinates will be 0, negative 3. Now we have the y-intercept. Next, symbolic rule. Again, I have the slope and I have the y value of the y-intercept. So I get my rule, y equals 1.5 x. And now in this case, we are at minus 3. Okay, now that's our rule. Lastly, our now next rule. Right, this will be now plus, because we still have a positive slope, we're increasing, 1.5 equals next, comma, starting at negative 3. Right, because that is our value of y when x equals 0. Right. So there you have it. If you do have any questions, please let me know. And that, we'll see you next time.